Good afternoon, everyone. My name is Nguyen from Northwestern Medicine, and thank you for attending my talk. And thank you, CGC, for providing me the opportunity to present about my study. Today, my goal is to introduce about the chromosome microarray analysis workup for hypocellular MDS patient with inconclusive cytogenetics. We know that the identification of the chromosomal abnormalities are important for the prognosis, diagnosis, and therapeutic decision in MDS patients. And chromosomal abnormality classify MDS patient into different prognostic subgroups based on both the number and the type of abnormality. For example, patient with single deletion 11q has very good prognosis. And on the other hand, patient who has more than 3 abnormality will have very poor prognosis with the lowest median survival. Even though the chromosomal abnormalities are important, sometimes they are not available in some patient population, and we define those patients as inclusive cytogenetic or unsuccessful karyotype, which define as the patient have either 0 or fewer than 20 analyzable metaphase. For my study, we focus on the hypoplastic MDS patient with inconclusive cytogenetics. The hypoplastic MDS is defined as the bone marrow cellularity is less than 30% in patients younger than 70 years of age or less than 20% in those who are older than 70 years of age. And WHO 2022 classify hypoplastic MDS as a distinct MDS subtype. Though patients usually have more severe cytopenia, better prognosis when they are treated with the agent using a aplastic anemia patient such as anti-thymocyte globulin, or they have higher response to immunosuppressive therapy. Because of the hypoplastic bone marrow, sometimes it's very difficult to culture these patients for karyotype by conventional gene banding. We hypothesize that chromosome microarray as a DNA-based technique can be a feasible alternative method to conventional gene banding for hypocellular MDS patients. For sample selection, we went through 5,000 database cases and more than 600 unique patient diagnosis between 2016 and 2020. We found total 155 hypoplastic MDS at baseline and untreated. 37 out of 155, up to 24% has 0 or fewer than 20 metaphase. And 12 of the 37 has the DNA available at the baseline. All the 12 patients has the MDS diagnosis with a median age of 66. There's 7 male, 5 female with clinical follow-up available in 7 patients, and 5 patients had no mitotic cell, and the rest 7 patients had fewer than 20 metaphase. In this study, we used the Infinum Global Diversity Array GDA CytoSNP. This array is based on the bit array technology. The bit array is a silicon waffle which contains a million of bits on their surface, and each bit is coded with hundreds of thousands of DNA oligonucleotide probes specific to the locus of interest. When we apply the DNA fragment onto the array, each fragment will bind to, each probe will bind to a fragment of interest, and then we perform the single extension and then fluorescent dye. This array is a 3-day workflow, start from array processing to array scanning. Array processing include whole genome amplification on day 1, then incubation overnight. On day 2, we fragment the DNA into into 300 to 600 base pair, then purify using isopropanol precipitation, buffer resuspension, and then hybridize onto the big chip. On day 3, we perform the single base extension and then scanning using iScan and data analysis using Nexus Clinical. Our criteria for analysis is the copy number variation greater than 250 kilobase and the CNLOH greater than 10 megabase. After running the 12 case with the GDA cytosnip, we identify a total of 36 copy number change in 12 patients, and the most prevalently abnormality is copy number loss, 26 events, followed by copy number gain, 9 events, and 1 CNLOH. You can see on the left pie chart over here, 32 of the 36 up to 89% copy number chain detected by SNP array as considered additional copy number chain in 9 patients, and 12 of the 32 up to 38% as considered critically important in total of 7 patients. This graph indicates the distribution of the 12 important additional copy number chain detected by SNP array compared to conventional banding analysis. We can see the abnormality on chromosome 3, 5, 7, 12, 17, and 20 on the x-axis. And on the y-axis is represent the number of cases we observe those change. The most abnormality we see is the loss of chromosome 12 seen in 4 patients. The abnormality of chromosome 5, 7, 12, and 20 are only copy number loss. We only see 1 copy number gain and 1 CNLOH. I am going to explain more detail about this abnormality in the next few slides. For the loss of 5q in patient 7, 11, and 12, they usually have good prognosis for MDS patients and associated with important genes such as EGR1. Loss of 7q in patient 12 usually have poor prognosis associated with poor overall survival and important genes such as EZS2 and CUX1. There are 2 patients had loss of 12p and 2 had loss of the 12q. We know that the loss of 12p is associated with good prognosis and ETV6 gene. Patient 11 and patient 12 has CNLOH of 17p and 17p loss associated with TP53 gene, also associated with poor survival for the patient. Loss of 20q in patient 4 had good prognosis and important genes such as ASXL1 genus. This table indicates the therapeutic implication of the CMA finding in our study. Deletion 5q in patient 7 and 10 have good prognosis, and the patient may respond to the lenalidomide treatment. For patient 12, this patient already have TP53 mutation, and the presence of TP53 deletion will make it biallelic, which very poor prognosis and may indicate resistance to chemotherapy. All the 12 abnormality we found also confirmed by 2 methods, include Algerian SNP array and FISH. In conclusion, there's a high prevalence, up to 25% of inconclusive cytogenetics in patients with hypoplastic MDS in our study. The chromosome microarray provide the additional cytogenetic information, which is clinical relevance in MDS patients, and therefore we recommend that CMA should be a primary tool for cytogenetic workup in patients with inconclusive cytogenetics. I want to say a big thank you to everyone who kindly and generously helped me make this project happen. It's not easy without you. And that's all I have. Thank you for your time.